Let me give you an explanation on similar triangles. So let's consider this triangle 3, 4, 5, a right angle triangle. If you double the length, it would be 8. If you triple the length, it would be 12. If you double the height, it would be 6. If you triple the height, it would be 9. What is this length here? So let's use Pythagoras. So x squared equals 8 times 8 would be 64. 6 times 6 would be 36. Add the two together. 100, square root both sides, so x equals square root both sides, it would be 10. So this length here is 10. Let me work out this length here. So x squared, using Pythagoras still, 12 times 12 would be 144, plus this squared would be 81. Add the two together would be 225. Square root both sides, it will be 15. So this length is 15. The point I'm trying to make is that if you enlarge this by a factor of 2, so remember this is multiplied by 2. This is multiplied, the height is multiplied by 2. The diagonal length is multiplied by 2 as well. Now if you multiply by 3, so the length is multiplied by 3, the height is multiplied by 3, the diagonal length is also multiplied by 3. The point about similar triangles is that all the length, when you enlarge the length and the height by a factor of 2, the diagonal length gets multiplied by 2, and so on. So if you multiply by 4, the same pattern occurs. Multiply it by 3.8, the same pattern occurs. And also let's look at the angle. So let's look at this angle here. Hang on. So looking at the angle, let's try and work out this angle. So this angle here will be, I'm going to use 10. So 10 the angle equals 3 over 4. So the angle inverse 10 equally to both sides. That will then give you this inverse 10, 3 over 4. You jump to a calculator. I've done it earlier and it came out to be roughly 37. So this angle here is 37. Let's work out this angle here. So 10, so I'm going to use 10. So tan the angle, let's call this theta. So tan the angle equals 6 over 8, 6 over 8. So what? So you would inverse tan equally to both sides. 6 over 8. The point is that this angle, if you punch this into a calculator, it will also come to around about 37. So because if you look at what's on the inside, you can always simplify this fraction. Divide top and bottom by 2, so that would be 3 over 4, which is the same as this over here. This is the same as this. The point is that when you enlarge the length and the height, the angle stays the same. This for sure would be 37 as well. And you can use the same argument for this angle. So you can use the same argument for that angle. Hang on, let me clean this up. So let's work out beta, this angle here, beta. So I'm going to use tan. There are lots of ways of doing this. I'm going to use tan the angle. Remember, tan is this thing here. So tan beta equals not 3 over 4, but 4 over 3, because this is tan. If you think about it, tan is here because our angle is over here. And then, so beta would be inverse tan, 4 over 3. If you jump to your calculator, it will come to roughly about 53. Now use the same argument on this. Let's call this beta. So tan beta equals 8 over 6. 8 over 6. So beta equals inverse tan 8 over 6. By the way, this 8 over 6, you can simplify it to this. The point is that this angle would be 53 as well. This will also be 53. All the angles would be the same. So when you have an enlargement of, let's say, a factor of 2, all the lengths gets doubled by 2, but the angle stays, the two angles will remain the same. The two angles will remain the same. So because all these triangles are similar, we call them, we're going to say all these triangles are similar because they are similar to each other. So when you have an enlargement of a number, the angle stays the same. Okay, so we say that all these triangles are similar.